Did a thought came into your mind about mathematics, calculus, algebra, and other stuff about mathematics? Well, for some reason, we don't need mathematics in our daily lives, right?
Well, you are wrong.
Hmm.
Good day, viewers. So today we will talk about calculus. Did you know that calculus is the study of change? And it is derived from the Latin word pebbles and stone. Another fun fact, the father of calculus and inventor was Isaac Newton.
Ooh.
So speaking of calculus, today we will going to tackle or discuss limits. Limits is the value that a function approaches as the input approaches some values.
And there are three ways to solve limits. The first one is the tabular values,
The second one is limit theorems.
and the third one is a direct substitution.
For this video,
We will only talk about tabular values, the steps in solving, and some examples.
the steps in solving tabular values. First step, draw two tables and label each table on the upper left with X and label the upper right as f of X. Second step, take a look to the number that X approaches to, then label the first with greater than the number that X approaches to, and the second table with less than the number that X approaches to.
Third step, always take note that we will always start at 0.5. It may be less than or greater than but close to the given approaching number. And the fourth step and final step, substitute the value of x in the table using the given formula.
Here are examples. First example is limit quantity x minus 2, 5 minus 2x over x minus 2, which is x is approaches to 2. First, we're going to draw two tables, which is x is greater than 2, then x is less than 2. In the first table, since x is greater than 2, you need to take a number that is greater than 2 but closely approaches to 2. Then, always take note that you always start at the 0.5. So, 2.5, then 2.1, then 2.01, and 2.001. After you get this value of x, when you substitute this into this equation, so that you can get these answers, which is 2.5. When you substitute it, it is 0, 2.1, it is 0.8, in 2.01, it is 0.98, in 2.001 is 0.998. In the second table, it is x is less than 2, which is same process, 1.5 substitute to this main equation, so you'll get 2. This 1.9 substitute to this this equation, you'll get 1.2. And 1.99 substitute to this equation, you'll get 1.02. And lastly, this 1.99 substitute to this equation, you'll get this 1.002. Since both table is approaching to the 1, so the answer is 1. So that's how you solve tabular values. The second example limits x squared minus 4 all over x minus 2, which x is approaches to 3. So the first thing you do is draw a table x greater than 3 and x is less than 3. Label x f of x for you not to be confused. X greater than 3, you need to take a number that is greater than 3 but approaches to 3 only. So 3.5, 3.1, 3.01, 3.001. 3.1, 3.01 is greater than 3 but approaches to 3. After you get this, you need to substitute to this equation, which is 3.5 substituted, you'll get 5.5. Substitute 3.1, you'll get 5.1. Substitute 3.01, you'll get 5.01. Substitute 3.001, you'll get 5.001. For this second table, substitute 2.5 to this equation, you'll get 4.5. Substitute 2.9 to this equation, you'll get 4.9. Substitute 2.99, you'll get 4.99. Substitute 2.999 to this equation, you'll get 4.999. So, since the both tables is approaching to 5, so the answer is 5.
Example number 3. Limit of 2x minus 6 as x approaches to 1. First, we make a table, two tables, and label them with x greater than 1 and x less than 1. Then, label the left side with x and label the right side with f of x in each table. And then, we need to find values of x that is 0.5 greater than 1 and approaching to 1. Then, for the less than, we need to find values that 0.5 less than 1 and approaching to 1. In the first table, in the greater than 1, the values are 1.5, 1.1, 1.01, and 1.001. To find the value of f of x, we need to substitute the value of x in every x in the given formula. So, the 1.5, the f of x of 1.5 is negative 3. The f of x of 1.1 is negative 3.8. The f of x of 1.01 is 3.98. The f of x of 1.001 is negative 3.998. And in the other table, the f of x of 0.5 is negative 5. The f of x of 0.9 is negative 4.2. And the f of x of 0.99 is negative 4.02. And the f of x of 0.999 is negative 4.002. Since both answers are approaching to 4, the answer is 4. I am very sorry. Since both answers of both tables are approaching to negative 4, the answer is negative 4. Example number 4. The limit of x squared minus 12x plus 36 as x approaches to 2. First, we need to make a table of 2 and label each table with x greater than approaching number or x greater than 2 and x less than the approaching number or x less than 2. Then label the left side of the table with x and label the right side with f of x. So, as we are done labeling each table, we need to find the values of x that is greater than 2, which is 2.5. Always take note that we must always start with 0.5. So, the preceding numbers are the values that are approaching 2. So, the preceding values are 2.1, 2.01, and 2.001. Then, we need to substitute the values of x in a given formula. So in the first volume of x, the formula must be 2.5 squared minus 12 times 2.5 plus 36. And the answer of that, or the f of x of that, is 12.25. For the 2.1 is, the f of x is 15.21. And the 2.01, the f of x is 15.92. For the 2.001, the answer is 15.99. The other table, the values of x are less than the approaching number or less than 2. So we need to find values that are less than 2 and are approaching to 2. The first value is 1.5. Then the preceding values are 1.9, 1.99, and 1.999. Like in the other table, we need to substitute the values of x in the given formula. So the first value will be, the first value substituted to the given formula will be 1.5 squared minus 12 times 1.5 plus 36. And the f of x of that is 20.25. For the preceding value, 1.9, the f of x is 16.81. The 1.99 is 16.08. And for 1.999, the f of x is 16.01. Since they are both approaching to 16, the answer for the limits of x squared minus 12x plus 36 is 16. Since the definition, the steps in solving, and some examples are discussed, that will be the end of the video.
We hope that you understood the lesson. Goodbye!